flash burn. But the effects of depleting the ozone and changing the composition of the atmosphere would eventually come to the other side. And there the effects are unknown.
Statistically, this ghastly scenario has a 1% chance of happening once in the Earth's entire lifetime. But even these odds aren't reassuring if you're living on the planet at that very moment.
If you're caught in the beam, that's a bad day for you. If one of these happens in your galaxy and that beam is coming your way, go hide in a cave, because this is very high energy radiation. It's the kind of energy that will decompose your molecules, and you just don't want to be around when that's happening.
There currently are no defense measures to shield us from gamma ray bursts if they happen close to Earth. They travel at the speed of light, 186,000 miles per second. By the time we detect them, they will have already struck our planet.
Gamma ray bursts could pose a hazard to the Earth or to anything living that came within their bore site. But as we've seen, they're very infrequent. And there are other things in the heavens and on the Earth that are much more dangerous.
Cataclysms routinely erupt in some corner of the universe. And one day, something will snuff out Earth.
Most of the time, our ride around the sun is gentle and uneventful like this Ferris wheel. And as long as nothing gets in our way, we could go on like this for millions of years. But sooner or later, we know that this smooth ride will come to an end. We just don't know when.
Sadly, our planet's ultimate demise will probably come from the very thing that provides us life. Earth maintains a cozy lifestyle, being third rock from the sun. For over 4 billion years, the sun has been an ally, warming and feeding our planet. But in time, our solar heater will become our enemy.
The sun and the Earth have a unique relationship to each other. The Earth has a particular temperature, it's a particular size, it has life on it, and oceans, and those things depend on the sun. The sun is at the root of the existence of life on the Earth, and the sun will be at the root of its demise as well.
Earth's relationship with the sun will become dysfunctional when our solar mother really turns up the heat.
The sun gets hotter because it's burning hydrogen into helium. 4 hydrogen atoms become 1 helium atom. That means there are fewer particles bouncing around inside the sun. And that process basically means that the sun has to get hotter and brighter to hold itself up.
As the sun's core gets hotter, its outer parts will swell in size and turn red.
If you have a bonfire, you have all this wood there, you build it up, and at some point enough logs get burnt and the thing collapses and you get this huge burst of sparks and it gets much brighter. In a sense it's like that because the sun is right now burning hydrogen into helium, and the helium is the ash of that, if you like. And then as the sun collapses enough, the ash relights and the helium burns into carbon. And that's when things get really hot.
At this point, the sun will expand into a red giant and incinerate most complex life on Earth.
When the sun becomes a red giant, it will grow to 30 times its size. So the surface of the sun will actually be out beyond the orbit of Mercury. The luminosity of the sun will go up by like 1,000 times. And that's going to make the Earth so hot that the outer crust, the rocks, the solid part of the Earth, will melt. The whole planet would be a glowing ball of lava.
The sun will fry the inner planets, and even though the sun will become red and cooler, the Earth will be much hotter. Just leave the Earth a burnt cinder, like a charcoal briquette. So that would be bad for life on Earth.
And the Earth's hellish fate isn't over. As a red giant, the sun will fluctuate in size before collapsing into a white dwarf.
The sun that was huge suddenly becomes the sun that's very small and extremely dense. It's only about the size of the Earth, sitting down there at the center of our solar system, very much fainter than it used to be, and then everything cools off. And then that object is no longer generating energy either, so it begins to cool as well. So the final fate of the solar system will be to cool off and freeze.
Humans will probably have relocated to another planet or become extinct before the sun turns Earth into a snowball. However, the sun may dry up our world much sooner.
The sun doesn't get us at the time of the red giant phase. It may well get us earlier by just becoming bright enough to cause the oceans to evaporate. Water is an essential component for all life. And so if the Earth actually loses all its water, then that's another reason why life might disappear from the Earth, and it would again be the sun's fault.
There may be ways for Earth to win a stay of execution.
As the sun is swelling, it also begins to lose mass much more rapidly than it's losing it now. And of course, if it's getting less massive, it has less of a hold on the Earth will move further out into a larger orbit. And so it's kind of a race between the growing sun and the growing heat from the sun and the Earth actually moving, a little bit away from that fire that's getting too hot.
If our planet somehow manages to avoid getting fried or frozen by the sun, its future remains increasingly bleak.
This place is full of adventure. Rides that put your stomach up into your throat, things that collide, scary stuff. It's a lot like riding around the sun on planet Earth. But when Earth gets smacked or when things start to come apart, the ride could really be over.
I don't know what that means for the universe to end, because I like time. I live in it. So it's hard to imagine time ending.
Today, scientists contemplate our inevitable fate. In the distant future, the Earth and the entire universe may face the ultimate cosmic monster. No one suspects that Earth's most lethal enemy lurks amongst the stars. But in the future, and without prior warning, a cosmic Grim Reaper will unleash the ultimate Armageddon. The dark villain will stretch apart the universe. Galaxies themselves will split apart. Stars and planets will tear to shreds. The ultimate apocalyptic event is being called the Big Rip. And when it begins, it won't stop until every atom and nuclei in the universe are mincemeat.
The Big Rip, it really is the end of the universe. It's not like we're the last ones at the party wondering what's going on and we can go do something else. It's really like you've turned off all the lights and the universe just ends.
Innovative physicists Robert Caldwell and Mark Kamienowski proposed the notion of the Big Rip, a grim hypothesis about the final fate of the universe.
We used to think that the universe, which is currently expanding, could reach a point of maximum expansion. The Big Rip is the idea that the expansion will not only continue and accelerate, but rip everything apart as it does so.
Caldwell and Kamienowski calculated that the universe is expanding at an alarming and increasing pace, and that something is sucking everything outward like a vacuum. Acting like a galactic vice squad, these young scientists hunt for the cosmic killer. They believe a mysterious phenomenon called dark energy may be the culprit.
Figuring out what dark energy is probably the #1 goal of cosmologists today. Dark energy is dark, so you can't see it. We can feel what it is. We feel it through its effects on the gravitational behavior of the universe. There could be some dark energy in this room, under the chair. It's only when you look at its properties on really big cosmological length scales, billions of light years across, that you start to see the cumulative effects of the dark energy. It causes things to be pushed farther away from each other and contributes to the expansion of the universe in a quickening pace.
Edwin Hubble, whom the Hubble telescope is named after, first discovered the universe is expanding back in the 1920s. But it wasn't until 1998 when a crack team of scientists measured that this expansion is moving like a runaway train.
A nice analogy is to imagine that the universe, our three-dimensional space, is like the surface of a rubber balloon that I'm blowing up. Okay, I'm going to blow up the balloon as a demonstration of the effects of the expansion of the universe. As the balloon gets bigger, that's a depiction of the expansion of galaxies.
There's a galaxy. Another one.
Where's our galaxy?
Okay. We live there.
Okay, that's our home. As the universe expands, every other galaxy gets farther away from us.
In ordinary expansion, each galaxy stays the same size. But if you have super accelerated expansion, then the galaxies themselves can each expand, which is sort of what's happened here.
If I could blow it up fast enough to depict a big rip, then the balloon would explode. That's like space-time not being able to take it and coming to an end. So instead, we'll just pop a hole in the balloon. That's the big rip.
According to Caldwell and Kamienowski, the universe has no hope of surviving the Big Rip. They've even come up with a countdown to this apocalyptic event.
The Big Rip kind of rolls up its sleeves and progressively takes apart the universe layer by layer, working from the outside in, going from the largest scales to the smallest scales. 1 billion years to pull apart clusters of galaxies, then hundreds of millions of years to pull apart galaxies themselves, and then down to the size of a solar system, we're talking hundreds of thousands of years, and then to tear apart the Earth itself would take less than an hour. It's kind of interesting to think about what that would look like. If I'm in my protective capsule watching things happen, I would see this wall of darkness that starts coming towards us. I would no longer, at that point, be able to see any stars. The Earth, layer by layer, will be peeled off and ejected away.
Everything in us, the molecules that hold us together, would get ripped apart, and every atom that makes up your body would fly off to infinity in a very short period of time.
Fortunately, mankind doesn't need to lose sleep over the Big Rip. Caldwell and Kamienowski estimate that it will climax 50 billion years from now, when the universe is over 3 times its current age.
What's really fun for us is to try to figure out whether this is actually what's going to happen, to paint the science fiction scenario of what might happen and to think what might happen to us.
Deep space threats are real. Some could harm us tomorrow, others in the far future. But one thing's certain, something will terminate Earth and probably the entire universe once and for all. It's only a matter of time.
You wouldn't get flash burned, but the effects of depleting the ozone and changing the composition of the atmosphere would eventually come to the other side, and there the effects are unknown.
Statistically, this ghastly scenario has a 1% chance of happening once in the Earth's entire lifetime. But even these odds aren't reassuring if you're living on the planet at that very moment.
If you're caught in the beam, that's a bad day for you. If one of these happens in your galaxy and that beam is coming your way, go hide in a cave, because this is very high energy radiation. It's the kind of energy that will decompose your molecules, and you just don't want to be around when that's happening.
There currently are no defense measures to shield us from gamma-ray bursts if they happen close to Earth. They travel at the speed of light, 186,000 miles per second. By the time we detect them, they will have already struck our planet.
Gamma-ray bursts could pose a hazard to the Earth or to anything living that came within their bore site, but as we've seen, they're very infrequent. And there are other things in the heavens and on the Earth that are much more dangerous.
Cataclysms routinely erupt in some corner of the universe. And one day, something will snuff out Earth.
Most of the time, our ride around the sun is gentle and uneventful like this Ferris wheel. And as long as nothing gets in our way, we could go on like this for millions of years. But sooner or later, we know that this smooth ride will come to an end. We just don't know when.